In this video, we're going to take a look at dividing rational expressions. So let's start with this basic example of 1/2 divided by 3/4. So you want to start with 1/2 and you want to multiply it by 4/3. So instead of dividing a fraction by another fraction, we always multiply by the reciprocal. You might have heard the phrase keep it, meaning keep that first fraction like it looks. And then change it, meaning change the sign from dividing to multiplying. And flip it, meaning flip that second fraction. So it's a nice phrase that helps you remember to multiply by the reciprocal instead of dividing a fraction by another fraction. And then you just want to multiply across the top. So 1 times 4 is 4, and multiply across the bottom, and 2 times 3 would be 6. Then we can always just reduce fractions when we can. So 4 and 6 both divide evenly by 2. So we would end up with 2/3. So let's look at steps to dividing rational expressions. So our first step is to do the keep it, change it, flip it, or multiply by the reciprocal. Then the next 3 steps are just like what we did for multiplying and simplifying. So we want to factor everything out, we want to cancel common factors, and we want to write out the expression in simplified form. And of course we have to state the restricted values since we're dealing with fractions. So those restricted values are the same thing they were on the previous lesson, but let's write it down again just to reiterate it. So they are values of the variable that make the denominator equal to 0. Let's write that out. Values of the variable that make the denominator equal to 0. Okay, so we just have 3 examples of dividing. In this first example, we're going to start out by keeping it, changing it, and flipping it, or multiplying by the reciprocal. So keep it means keep this first fraction as it is, so I'm just rewriting everything. Change it to multiplying, and then flip the second fraction around, so you have x minus 2 times 7x minus 5 over 5 times x minus 4. Now they've already factored this one out, which could happen sometimes. They might give it to you in factored form. So we just now need to look at common factors in our numerator and our denominator. So we have x minus 4 in the numerator and x minus 4 in the denominator. We have x minus 2 in the numerator and x minus 2 in the denominator. So let's just cancel those out and bring over what's left. So we have negative 7x minus 5 in our numerator, and we have 5 times 3x minus 2 in the denominator. So that's our simplified form after we've divided, and we just need to state the restricted values. So if 3x minus 2 were to equal 0, we need to solve for what value of x that would be. So if we add 2 and divide by 3, we'd say x would equal 2/3. So in other words, x cannot equal 2/3, or it would make that value 0. And then x minus 2 means that x cannot equal 2, because 2 minus 2 would be 0. And for x minus 4, think about 4 minus 4 would equal 0, so x cannot equal 4. So we say x cannot equal 2/3, 2, or 4. Those are our restrictions, the restricted values. Excuse me. Number 2. So for this one, let's start the same way. So you want to keep the first fraction like it looks. So I'm just going to rewrite it. We want to change it from dividing to multiplying, and then flip the second fraction. Notice it's now a multiplying problem. So after that very first step, you're actually now back to multiplying, which is what we've already talked about before. So that's why we're only going to go over 3 examples of these, because they turn quickly into what we talked about in our previous lesson. So now let's factor everything out. So in my first numerator, I have a basic trinomial. So we need to multiply to get negative 15 and add up to get 2. So let's factor into x plus 5, x minus 3. In the denominator, we have a difference of 2 squares. So the square root of 16 is 4. So I need x plus 4, x minus 4 for my factors. In the next numerator, we have a greatest common factor of 3. So when you take out 3 from 3x minus 12, we get 3 times x minus 4. And then leave the x plus 1 in the denominator. So now we look for common factors in our numerator and denominator. So x minus 4 is in the numerator and it's in the denominator. But then that is all that we could cancel, and that's okay. Don't force things to cancel that don't cancel. So we bring over 3 times x plus 5, x minus 3 for the numerator, and then in the denominator we have x plus 4, x plus 1. And just leave it like that. Don't try to multiply those together. It's not necessary unless it shows up on a test question where you needed to. And then let's state our restrictions. So if we have x plus 4, x cannot equal negative 4. If we have x minus 4, which we do, x cannot equal positive 4. And we have x plus 1, so x cannot equal negative 1. Those are values that would have made our denominator equal to 0 in one of those spots. Okay. Let's do one more example of dividing. So in our first step, we're going to keep the first fraction like it looks. So just rewrite it. Change it from dividing to multiplying. And then flip the second fraction around. So the numerator is the denominator and the denominator is the numerator. All right, so then notice it's a multiplying problem now. And we just need to factor everything out. So we have a basic trinomial in our first numerator. We've got to multiply to get negative 2 and add up to get 1. So that'll be x plus 2, x minus 1. Just bring down the x plus 5 in the denominator. And then we have a difference of 2 squares in our second numerator and a basic trinomial in the denominator. So our difference of 2 squares, the square root of 25 is 5. So we have x plus 5, x minus 5. Then we need to multiply to get 2 and add up to negative 3. All right, so that'll be x minus 2, x minus 1. Those add up to negative 3 and still multiply to be positive 2. So then in our numerator and denominator, we have x minus 1, top and bottom, and then x plus 5 matches. So those we could cancel out and bring over what's left. So x plus 2 times x minus 5 is still left in my numerator, and x minus 2 is still left in the denominator. So that's our simplified form. You don't need to multiply the numerator together. And then x cannot equal what would make these factors that are in our denominator equal to 0. So if we have x plus 5, x cannot equal negative 5. If we have x minus 2, x cannot equal 2, and x minus 1, so x cannot equal 1. Because negative 5 plus 5 would equal 0, and that's not possible. And 2 minus 2 would equal 0, so that's not possible. And 1 minus 1, those would equal 0, and those are not possible. So we just write that x cannot equal those 3 numbers. Okay, so that's it for dividing rational expressions.